just briefly running through heavy weather sail plans. This is a boat in the Sydney Hobart. You can see what kind of waves they have. In this case, it's a number 5 jib and a Storm Trysail. As Dick had said, it's practicing on your own boat and knowing what your boat likes, whether it's sails or whether it's man overboard procedures. You got to practice with your own boat, your own crew. Starting from the moderate conditions, and it's amazing how these sail combinations seem to apply to almost all racing boats, despite their designs. And for cruising boats, you would change down sooner. So this is kind of just racing benchmarks. Number 3 in a main, and the ability to bend the mast and bring your lead aft and open up your slide and drop your traveler. That a full main and number 3 jib is okay on most racing boats up to call it the mid-20s. Then in this 27, 32 knot wind range, you start reefing. That doesn't mean you can't reef earlier. This is just a typical racing boat. Number 4, a smaller jib, not a deck sweeper. It's able to let waves, water underneath. You can tell that this boat is reefed and balanced beautifully. And the giveaway is the tiller is in the center. The boat is totally balanced and no sails or luffing. When you talk about sailing in breeze, all the way up from moderate air to hurricanes, you cannot allow your sails to luff. I mean, it doesn't mean you can't just drop your travel and luff your main briefly, but the more your sails luff, you're going to hit a point offshore after hours or days where your sails deteriorate and you lose your sails. Sails do not like to luff and shake for long periods of time. So you got to, on the offshore, you got to match your sails to both balancing the boat, but also preserving your sails. So here we are with a single reef and a 4. Very few boats like to have a 4 and a full main. It's not balanced. And another thing you find out at sea is the best way to, 2 ways to tell if you're balanced. One is the tiller in the middle, wheel in the middle. The other is when the boat's coming in and out of waves, launching off waves, is it twisting and corkscrewing. So in effect, you want it balanced in the water and in the air. After the 4 and single reef, there's a close-up. You can see the tiller. By the way, the reef points. It's not necessary to tie your reef in. It's neat. It helps. You can see your instruments on the mast. But if you tie your reefs in, do not use rope. Do not use the sail stops. Use shock cord, because if something slips, like your reef outhaul, you don't want to have these claw mark rips in your mainsail as the sail frees up and your ropes in your reef patches rip out. Shock cord gives you that chance to save your sail. Now we're in with a number 4 and a double reef. Now the wind's up into the 30s. Now this boat has a heck of a lot of hiking power on it. We all don't have that many people, particularly if you're cruising, but she is balanced and going fast. Here we are now with a double reef main and a storm jib, somewhere around 40 knots. Now it's interesting. The head of the mainsail is up at the second spreader. You can see on this sail, we put patches, reinforcing patches on the luff of the mainsail, these finger patches, so that whether you're full hoist, 1 reef or 2, there's a patch that will match the spreader. So if you're running, your sail doesn't rub against the spreader and get damaged. So if you're an offshore boat, you just don't have a spreader patch for your full main. You have it for all your different reefing locations. And then this is the full-on Storm Trysail Storm Jib. It takes you up to probably 60, 70 knots, at which point you got to figure out which one you want to take down. It depends on what point of sail you're on. In this case, the trysail is trimmed to the boom. That's not the conventional way. Conventional way is you have 2 sheets on it, 1 to each quarter, kind of to your spinnaker blocks. Got to be careful the crew in the cockpit don't get hit by flailing sheets. That's the way you set it. That's kind of a norm, but we find that if we know we're going to have it up for a while, we end up transferring it to the boom, and it's something got to practice because it's not a slam dunk. You don't know where to do it. But if we're out at sea on my Express 37, we're going to be caught in a hurricane. We strip the main off the boom, turtle it and shove it below because it's too much windage. And it also, if a sea hits us from the side, that extra area of mainsail hanging over the boom could contribute to us being rolled over. It's an extreme thing, but if you're going to be out there in extreme conditions and prepare for it, one thing you would consider is stripping the main and putting up the trysail, which means doing it well ahead of time. Just another photo of it, just demonstrating it to the college kids. If you're going to practice with storm sails, you don't wait for the storm. You go out on a nice day and you play with them. That's my partner, Rich Wilson, finishing the Vendée Globe race, triple reef main, sole and jib. He did 2 Vendée Globes. He finished both, which is quite unusual for a skipper to be able to actually finish 2 in a row without something going wrong. And this is Sydney Hobart with the front coming in the Bass Strait. And we'll show the film later. But you can see the reef lines are always lead for the mainsail. And in this case, we have a 3 up one, before we need it. And before we know it, we were in a 4 and a double reef, but at least we're semi-prepared for this one. And there, instead of stripping the main, they tightly furled it. But you could see the area that might present to waves hitting the boat. Now, heavy weather sailing, now that we've seen the sails. Again, it's not just the safety equipment. Rod Stevens, on the left at the bottom there, and his brother Olin Stevens, preeminent designers. But Rod Stevens was an incredible seafarer, and that's Dorade, the boat that they designed and built and won the Transatlantic Fastnet back in the 30s. Rod said that fundamental seamanship has physical attributes of both the boat and the people, the vessel awareness, knowing about your boat, core competencies you need to have to go to sea properly prepared, psychological factors. And then there's the vessel seaworthiness and the safety gear. And again, Rod talked about the owner being the responsible person, and preparation requires lead time with both the boat and the crew. Every system on board must be tested before you go out to sea. And it doesn't take that long. In a couple of days of sailing, you can test everything you got on board. And if you're ready for heavy weather, then you're ready for anything. So preparing for the heavy weather is key. Nobody has to, sure, you can practice your light air sailing, but that's okay for racing. But what's going to help you at sea is being ready for the other end of the spectrum. Think Shackleton. We've talked about that. Channeling the skills and energy of the whole team, the situational awareness, resetting goals, and optimism. So 3 initiatives. One is selecting the crew in the boat, getting the right people with you, compatible, fun, skilled, experience. Preparing them, and then planning the voyage itself. The crew selection, all this is going to be available later, so I'm not going to go through it all, but these are the kind of basics of what you would want to think about with the crew. And I have to stress the one that Shackleton used and the one that I try to use is humor. Why go to sea with people who have no sense of humor and can't find the kind of the fun and the humor in certain things going on? Boat selection coming from Rod Stevens, who was as knowledgeable as anybody who's ever lived. And he came up with these back in the 50s. So he really knew what he's talking about, the stability, the structure of the boat, how it steers, the steering system, how effective is it, what's your backup, the ability of a boat to heave to. This was the basic way that old ships survive storms. And yet it's kind of been forgotten. And the quick stop in Man Overboard kind of brought it back, because when you're doing that quick stop, you tackle over with your jib back, you're in effect heaving to. So all of a sudden, there's a value to heaving to. And the rig, you definitely want to inspect it, and you don't want to have to be thinking, is it going to fall down today? The motion and livability of a boat. We know some of the modern racing boats are really bad in both these regards. And generally, the bigger the boat, the more seaworthy it will be, all other things being equal. So if you're thinking of going offshore, you kind of want the biggest boat you can afford, not the smallest. The crew preparation, there's all these things from clothing to safety gear, watch systems, safety habits. We'll be picking some of these up later on. And again, know your boat. It keeps coming back up again. Know the drills. Boat preparation, checking things like watertight integrity, the pumps, the rig, the sails, the reefing. No way to know how good they are until you actually try them. You got to reef and unreef a bunch of times to know whether your reef outhaul's in the right location on the boom, for example. So it's really a matter of going through the list and doing it yourself on your own boat. Reading about it's great. Going to a seminar is great, but the knowledge has to go beyond your head. It has to go into the operation of the boat. The lower right corner is an example. My forward hatch leaked like crazy. Big hatch on a lightweight boat, and so we built these aluminum little reinforcements that we just put around the edge, 3 sides of the hatch. Now it's rigid. I've never had a drop of water since. Voyage planning and strategy. Ed's going to be getting into some of this, but your pre-departure and your key decisions. Do you leave? The Bounty 2 left New London to go around Hurricane Sandy. Bad decision. The race at Dauphin Island, some tough decisions there. So the seamanship starts before you leave the dock. And then you've got, of course, access to all these different helps like weather updates. Ed will talk about that. Maintaining a log, I find, if you're going offshore, is important because it keeps your head in the game to put every hour into a log the statistics of where you are and what's going on. And as you and your crew get used to maintaining a log, things become apparent you might have missed. The other interesting thing is if you lose your electricity and your GPS goes off, where the hell are you? You haven't written down for days where your latitude longitude was. So having it is a great backup to your instruments. Every watch inspecting the bilge, for example, and then the rest of storm tactics and communications. Your typical northern hemisphere low with the warm front preceding the cold front, southeasterly winds above the warm front, fog, rain, not too windy unless it's a deep low. Then the warm front comes through, clears up a little, southwest breeze, and then the cold front, which can be much more dynamic with a northwester behind it. The dangerous quadrant in the northern hemisphere is the front right quadrant, the northeast quadrant, because the storms tend to arc to the right, and the other is that the wind in front of the warm front is from the east. So if you're directly in the line or just off to the east of the line of the low, the wind is pushing you in front of the low into the storm. Not where you want to be. You do not want to be in this section with the storm approaching, big storm approaching. You either want to get the hell to the right or you want to cross it and get way off to the left, but you don't want to wait till it's too late. The other is as the storm moves north, the right side of the storm, the wind speed plus the velocity of the low moving adds to the wind, whereas on the west side, the wind's going one way, but the low's going the other, so it's not quite as windy. These are races where you had hurricanes or lows that reach hurricane velocity, or in the case of Dauphin Island, a cold front coming through. 3 boats finished the 2006 Vineyard race in Hurricane Ernesto. All 3 were the Storm Trysail Club team, so we were very pleased with that. And many of your speakers were on various of these boats. Sydney Hobart race, again, getting prepared for storm. Letterbox takedown is interesting. A letterbox takedown is what you do offshore, or if you're expecting some very bad weather and you're not going to have to jibe immediately. It's the safest way to take down a spinnaker. Picture says 1,000 words. So let's look at this. The reason it's worth the time is because we're going to get back to this with man overboard scenario. What happens when it's too windy to do a quick stop and luff the boat into the wind and you're offshore? If it's blowing that hard, you don't want to take a spinnaker down your foredeck. So offshore boats rig for letterbox takedowns in heavy air. On this boat, Carina, our transatlantic races, we always were rigged for letterbox, even in medium air, because it was our go-to safe way of taking down a spinnaker. You can't really use this in round the buoy so much. It takes too long to clean up, but for offshore, it's the way to go. In our case, we'd set the ASIN with 3 sheets. The 3rd sheet was our take-in line. Or you can take your windward spinnaker sheet around a leeward and tuck it over your boom and under your mainsail. Or you can take just a line up through the boom mainsail and clip it to the spinnaker sheet and pull it in that way. But the key is no one on the foredeck, no foredeck hatch open, totally seaworthy, and pulling the sail in behind the mainsail so it doesn't fill with wind, and you're on the windward side of the boat so you're stable. The only warning is make sure the cook turns the stove off, because when this goes down the hatch, You don't want to melt your spinnaker. We learned that once the hard way. But just a zero risk way of taking down a spinnaker. So think about using it for offshore racing. Or if you're just doing a delivery and you have an ASIM up with a limited crew, only takes 1 or 2 people to do it this way. We use it for double-handed sailing if we don't have a sock on. This is the front coming through. This is what a Southern Hemisphere Australian southerly buster looks like. We have a preventer keeping our boom from swinging. Our preventer's led inside the lifelines, which is unusual, but it's easy because you never have to worry about your lifelines. Now the breeze is filling in. It's up to about 40 in the next few minutes. So the letterbox, having the right sails up. The mistake here is 2 of our crew don't have the PFDs on right now. And this is what heavy weather looks like a few hours later. This is not us, it's another boat. But they have a number 5 jib, a triple reef main, boat named Wild Thing. It's blown probably 50. And I would say they're over canvassed. It's amazing their rig stayed in the boat. They're trying to live up to their name Wild Thing, but they're Australians. And clearly excellent sailors, but really maxing out that rig. Look at the head stay flopping around when it hits the waves and the mast bending, but they made it. I think for most boats, a storm jib would have been better. And I'll end up on just the pictures of Dauphin Island because Ed will be talking about how you can be prepared and knowledgeable about what's coming and not get caught like the poor people at Dauphin Island. So please start sending your questions in to Chris Lewis for the Q&A to follow Ed.
Rich, I do have a question that's come through already from Mark.
Yeah.
On heavy weather sail plan, what for a catamaran, what would be some differences on the sail plan and point of sail as compared to a monohull that you've been showing?
The biggest difference in the catamaran or trimaran is the apparent wind that these boats generate. And on my time on Great American, a 53-foot trimaran, the one I did the Hong Kong trip on, for example, we would do our first reef at 14 knots, our second reef at 17 knots, and our third reef at 20 knots. It sounds crazy, but these boats load up so fast, build up such speed, and with a catamaran, you're risking capsizing and pitch bowling. You are with a trimaran, but the bigger risk with a trimaran is like skiing, where the weight's on the downhill, the tip of the forward edge of the downhill ski. The leeward bow of a trimaran is under huge stress, and so you don't want to overpower. So I'd say the crossovers on the reefs and going to the smaller jibs are very compressed on a multi-hull.
Okay, weather safety. Not a lot of time this morning, so we don't really have time for a full weather course, but we'll go through a number of things and talk about them kind of at a 30,000 foot level, which I think actually is one of the great things about these safety days. As much as, really the bit by bit content, which a lot of people on the call are experienced with and really kind of already know, it's a great opportunity to just sort of have a stand down and think about safety. And I think that's really as useful as anything else. So when I think about weather safety, what I think about is 3 kind of modalities: awareness, information, and then a process that you can synthesize awareness and information into good decisions and safe practices. Certainly this gentleman here in the dory has got himself a nice big halibut and is aware of that fog coming. So as I mentioned, we don't really have time to talk about technical weather stuff, but it's hard to really think about weather awareness without thinking about the synoptic picture and the big picture of the weather. So after the sun, the jet stream is the most important factor. And it's well described here in what many of you probably know and what meteorologists refer to as the 500 millibar chart, which is essentially a picture of the jet stream. And those lines on there are lines of ISO height, lines which describe common zones of a particular barometric pressure, in this case, the 500 millibar pressure. And the 5,640 meters is the dark line, which is essentially the line of storms. Below that line, you have a better than average chance of experiencing good weather. Meteorologists like to say it's the southern extent of 4-6 westerlies, which are 22 to 27 knots on the Beaufort scale. I love the Beaufort scale. It's totally charming. Also, not really useful. The Brits love it, but I find it more prosaic than useful. In any event, 4-6 below that line is rarely encountered. Conversely, 300 to 600 miles north of that dark black 5640 line is where one encounters storms. You can see this upper level low above the jet stream, and down and to the right is where you'll find the surface low. So again, with a quick glance, if this is a resource, and we'll get to where you can find it, you can have a really general awareness of what the sort of continental size weather's going on. And I think that's important to sort of begin with that kind of awareness. And there are plenty of weather courses that one can take where you can learn much more about this. I just point out two other things. These are so-called cut-off lows from the jet stream. They're important because they're really persistent. We'll get to this at the end of the talk a little bit. But if you are going somewhere or encountering, of course, your voyage planning or race course where there is a cut-off low, you can count on that for sticking around a while. And it's important to watch out for those. So down on the surface, this is the so-called synoptic chart. And again, we could talk all day about this stuff. And I've been to courses where we do talk about all day. Matt Gallagher has taken a terrific course available at University of Pennsylvania. I might be, actually it's Penn State. I'm sorry. Penn State offers a very interesting undergraduate meteorology course online. There are a variety of places where you can get great weather education. And I encourage you to do that if you can find the time. Some of these commercial centers like the MyTag Center in Maryland have great 2-day weather courses where you can learn all about this stuff. The surface analysis, generally speaking, under the ridges in the jet stream that we saw before, you encounter high pressure. And then here is a surface low pressure, right where it should be, about 400 miles north of the 5640 line, down into the right of the upper level row. As Rich duMoulin mentioned a little bit, cold fronts are where the action is. And you know, when you get right down to it, 8 in 10 times your weather maker is going to be a cold front. And that produces extreme weather at the boundary, as we all know, a sharp turn to the right in the northern hemisphere in the true wind direction behind the cold front, along with a sudden change in cooler temperatures, which is a significant factor. So important to have that overall awareness, get a little bit of it, get a lot of it if you have time and inclination, but some big picture understanding of what's going on the earth around you, I think is really a fundamental building block. Oh, I just found my laser pointer. Great, here we go. A fundamental building block of weather awareness and weather safety. Here's the jet stream 4 days later from the picture we saw earlier on. And I put this up because 96 hours is when forecasting still gets really good. If I'm thinking about an ocean race, I start to think about the weather 10 days out, which is when the easily available weather models are starting. In other words, if you look at the GFS, usually you'll see a 10-day picture of the weather. You can begin to look at it then, knowing that it's going to change a lot in 10 days. And then when you get to 96 hours, which is 4 days, models get really good. Meteorologists are now offering you products that offer both the human and the machine interface. And you can see here the weather, the jet stream has changed quite a bit in 4 days. It's changed from that big loopy presentation we saw before, which is known as the meridional flow because they go up and down with the meridians, to a zonal flow across the time zones. Again, we could talk all day about that stuff. And I urge you to get more information and training because it's pretty interesting. One thing I'd like to point out in this particular chart is this big crazy loop in the jet stream, sometimes known as an omega block. But what I want to emphasize is, as I've watched the jet stream over time, it's getting crazier and crazier. I mean, these kinds of huge, crazy loops are becoming more and more frequent in the jet stream, leading to more and more crazy weather patterns. But it's happening for sure. So, along with the big picture is little stuff. Most everyone will recognize this picture of wind barbs as they appear on weather charts, with each little half barb representing, everyone thinks 5 knots, first one 5, second one 10. Well, don't forget, there's one with no barbs that's 1 to 2 knots, which means each of the subsequent barbs really represent a 4-knot barb, but it's on the high side. For example, the 2-barb wind barb here, everyone thinks of as 20 knots, which is, oh, okay, 20 knots, great. Nice fresh day, not too much to worry about, but 20 knots, love sailing in 20 knots. Well, it's really 18 to 22 knots. And even more pointedly, the next one down, which you go, oh, 25 knots. Okay, going to be pretty sporty today, but 25 knots. No, that's 23 to 27 knots. And as most folks here probably have heard or know well, wind speed, dynamic pressure of the wind, the force of the wind increases at the square of the speed. So I'm here to tell you, and you all probably know just as well as I do, 27 knots feels like a lot more than 25 knots. So little things like that are important to be aware of. Again, maintaining awareness about the environment around you as you get ready to voyage and voyage plan, or get ready for the next watch and know how to advise who's coming on watch and what they can expect. Similarly, in the water, this is a chart that I don't use very much, but it's available from NOAA, describing the sea state analysis. In this case, in the Western Atlantic, the numbers here are sea state height in meters. And what this shows is significant wave height, which is a technical term and means the average height of the top 1/3 of all the waves. So the average height of the top 1/3 of the waves out here in the Gulf Stream is 15 meters, 55 meters, or a little over 15 feet. Given the fact that that's a significant wave height, there are plenty of 20-footers out there, probably some 25-footers, and probably some rogue waves. So important to understand what you're looking at when you're looking at weather products, making sure you understand what it is that's out there, and being aware that of the whole picture, and being aware that these are forecasts, and what you may encounter may be more severe than what has been forecasted. So in terms of weather awareness, the full suite of things that I focus on, getting ready for a race or getting ready for a watch at each sort of 6-hour weather interval, are these, and I kind of tackle them in this order. First of all, I look at the upper atmosphere to keep an eye on what's going on up there. That's the 500 millibar chart. Then I look at synoptic weather surface maps like we saw, which are available from the Ocean Prediction Center. I'll get to that in a minute. Then I look at model data. Important to remember that it's getting better and better, but it's just computer models. Then I look at text forecasts, kind of oft forgotten and underutilized. But text forecasts from NOAA give you a lot of information. It's tedious to read through them, especially at a chart table down below when it's hot and twisting around. But text forecasts are really valuable. And then observations, satellite imagery, if you can get it on whatever internet link you happen to have, either at home before leaving or on board. And then earth-based sensors, observations, buoy reports, ship reports, all available from NOAA. I'll get to that in a second. If it's not winter, important to check the National Hurricane Center. The National Hurricane Center gives you all kinds of information about tropical activity. And lastly, commercial weather services, which Rich touched on. I certainly get a professional weather forecast for every race. They're super valuable. There are a lot of good sources. I think that those reports and services from folks like Commanders or Chelsea Carlson or Chris Bedford, they're not that expensive, and it's money really well spent, no matter how much you know about the weather. Again, all contributing to weather awareness. As I mentioned, your tax dollars at work. The NOAA, the Ocean Prediction Center at that URL has 95% of what you need. just like the advertisement says, analysis and forecast, data, information, and news. I urge you to just go there and prowl around for an hour and see what's there, see what you like, see what's available and useful to you. Similarly, your local forecast website, your local forecast office with NOAA. This one is for Houston. They're all a little different. The one for New York is Upton, New York, Taunton, Rhode Island for the Massachusetts area, and they're all a little different. So I urge you to go to whichever local one is applicable for you and see what's available there. In Houston, this is what the front page down the page looks a little bit like. And again, this one's a little different than Upton, my home forecast office. And I like this. It's got a radar picture. That's not that great, really. This is the guts of it. And most all of them do have this forecast zone map, where if you click on a forecast, you'll get the marine weather forecast for that zone. I'll come back to this in a second. But down in Houston, they have this weather map, synoptic map, from the Weather Prediction Center, which is different than the Ocean Prediction Center. But I like this map because it's got a lot of graphics on it. If you're not as experienced in sort of reading the synoptic features and understanding weather maps, this is a great one. So I applaud Houston for putting that on there. Jumping back to the forecast map, you can navigate around using these arrows or zoom out. And if you hit zoom out, what you get to is this, which is a national map of forecast areas in very near shore forecasts, just offshore forecasts, and then ultimately high seas. Click on any of these and you'll get the forecast for that zone. So super simple. You guys probably all know about this already, but always important to remember that it's there and to check it. Chasing the exotic data is less important than thinking about the weather, thinking about how it's going to impact your voyage or your next watch, and utilizing the tools that are immediately available, of which now there are a lot. I'm sure everybody on this call has at least one weather app on their phone. I have like 10, of which I use maybe 3. And just to point those out a little bit, this is PredictWind, and there is a free version and a subscription version. I invite you to view what's available on the subscription versions and see what's applicable to you. Again, they're not that expensive. I find them to be good value. What I really like about PredictWind is it offers a ton of model data. All of these they've just expanded it. These are all the models that are available on Predict Wind. And of the weather apps, I think Predict Wind does the best job of displaying model data. This is a great format because you can compare up and down what one model is saying versus what another one is saying. If you see consistent numbers up and down the line here, then okay, that's a sign that all of the models are handling the weather pretty well, and you can increase your confidence in what they're saying, remembering that it's only computer generated model data. Here it has the GFS, our homegrown NOAA model, which has just gotten dramatically better, both through an update in the underlying algorithm that the GFS uses, and more importantly, in the increase in quality of the inputs that go into each model run. For a long time there, everyone was singing the praises of the European model because the inputs were better. Well, I'm happy to say we've really caught up, and I think the GFS, by and large, is running every bit as well as any of these now. PredictWind has their own in-house proprietary variant of each of those models. Some say these handle near shore conditions better. I don't know, maybe. But I think what's important is to compare all of them and see how well each one is running. The NAM down here is a variant of the GFS, which is a high resolution model, super valuable. We could talk for another hour about models, but we don't really have time. And I think what's important is knowing they're there, knowing what they're good for, knowing the consistency across them is the most important thing. One value easily obtained in PredictWind for each of these models is CAPE, which is a cumulative atmospheric potential energy. I don't think that's quite right, but what it is a good indicator of the convective activity, thunderstorm activity available in the atmosphere. So I always keep my eye on CAPE, particularly in the summer, particularly when there's a cold front approaching. Models are getting better and better and better, but they're only models. And one thing to keep in mind is you hear folks say, oh, Windy, which is that app with the streamlines, looks really cool. It's the same data as this table. It's all the same data, just displayed differently. Important to keep that in mind. The other app I use all the time is Sailflow, which is a different one. It also has a ton of model data, but what it does better than most, I think better than any, is observations. Here is a screenshot of my phone looking at the Houston area and the Gulf of Mexico area. You can see there's a large assortment of observation stations, which makes Sailflow really superior for observations. If one clicks through on each of these little stations, you get a whole bunch more information, a forecast, tidal information, model data associated with the forecast. Sailflow has a premium subscription version, which offers meteorologist-based professional forecasts for a number of different zones. Again, that's in the paid version, but it's super. So I encourage you to use these, not as a sole source, but as a great source of specific information in that kind of triangle I talked about earlier. Awareness of what's going on around you all the time, and then accessing specific information that can be useful, and then processing that information, which we'll get to in just a minute. Thirdly, for apps, and arguably the most important from a safety standpoint, Rich mentioned the Daphne Island incident in his talk. Clearly, radar was underutilized that day. I use two radar apps for kind of different purposes. Each of these also has a free and a subscription version. Most of what you want's in the free version. My Radar Pro on the left offers a great composite image of any geographic region as big as the entire United States of a variety of radar stations. So it gives you a nice overview of what's going on. This is from yesterday. I had to wait till some thunderstorms popped up. It was a super clear day 2 days ago. And I said, oh gosh, there are no images here. But yesterday we got some action. And My Radar Pro is a quick, easy way to look at what's going on around the region. It also offers the opportunity to lay over these synoptic features over the chart, which is kind of cool if they mean anything to you. If they don't, turn them off. And what's important is the radar image. A quick look at that suggests what I need to be watching for and how aware I need to be of potential thunderstorm activity. If things are hot, I jump to another one called Radar Scope, which Radar Scope is mostly free. And what you're looking at here is Radar Scope's image. It is, the issue with it, you need to select a single radar station, in this case, KEOX or KEQX. It has a feature which tells you where the local stations are and allows you to toggle from one to the other, but it only displays images from that one radar station. But once you've got it on the one you need, the images are of much higher resolution. It offers these little storm track barbs, which are very accurate, which offer both the vector direction of the thunderstorm and the rate of advance via these little hashtags. So obviously, radar imagery is super important from a safety standpoint. Got to have a cell signal to get these, but as long as you do, they're super valuable. From a satellite perspective, and I almost forgot about this one, and Chris Lewis reminded me. Oh gosh, I forgot to put it on. Is Sirius Satellite Radio. Offers a satellite-based product which displays on your chart plotter and gives you all kinds of great weather information, including radar by satellite, so you can get it up to 150 miles offshore. And I have used it, and the radar tracking feature in Sirius XM weather is uncannily accurate. You can watch a thunderstorm with lightning displays kind of chase you down, and I've watched one chase us down, and actually used it to take avoiding action, change course, and get out of the way. So I highly recommend that, and thank Chris for reminding me of that. So from a weather safety standpoint, that's radar imagery. And then there's good old NOAA weather radio on your VHF. Everybody's forgotten about this, but it's still there. And click to the weather band on your VHF, and you're going to get a NOAA forecast, which is highly detailed, includes observational data, and is just terrific. I remember back in the day, starting the day with a cup of coffee and NOAA weather radar, and sort of a great way to start off the day. One thing to think about when listening to NOAA weather on the radio, or really in gathering any of the information we've just talked about, super important to take notes. And maybe a good place to record those notes is in the deck log that Rich duMoulin mentioned. Super important to keep your deck log. And it's amazing how much you forget or mishear in listening to the weather, or reading a weather forecast, or reading a synoptic chart if you don't take notes. Now, did they say 33 knots or 23 knots? Did they say northwest or north-northwest? I don't remember. You forget right away. And if you don't take notes, you're really at a loss and putting yourself in a suboptimal safety position. So again, at a very high level, that's the awareness picture, the information picture, and then there's taking those two legs of the stool, combining it with the third, which is processing that information. And one bad habit I find myself always falling into is focusing too much on wind velocity and wind direction, which of course from a racing standpoint and a VMC standpoint, and trying to get to the finish line quickly is maybe the most important, but it is equally important not to become myopic about wind, because there's so much more to the weather. There's obviously sea state, there's precipitation, which the boys want to know about, particularly leading up to a race. Everyone wants to know what kit they need to bring. So as I do my weather forecast for the crew, starting about 5 days out, I'll do a weather forecast email to the whole ship's company every morning, maybe twice a day as we get closer. They want to know, okay, Ed, how much rains are going to be? What do we, what's it going to look like? obviously thunderstorm activity. Another big one is temperature, which has a huge effect on crew morale, safety, and operational readiness. You need to be thinking about temperature and moon phase. Okay, how much light we going to have on Thursday night when we're 2 nights out? And this picture, here comes a cold front. As I said, maybe 8 and 10 times your weather marker is going to be a cold front. Super important from a safety standpoint, simply to keep your head out of the boat. I mean, this isn't going to be a roll cloud southerly buster like one would encounter in the Bass Strait, but that's a pretty ugly looking cold front. And there's going to be a lot of wind at the front end of that thing. Going to be a big wind change. Temperature's going to drop. Notice the folks in the cockpit there are not dressed for what's coming, neither with respect to their clothes or with respect to life jackets or safety tethers. Obviously, they're out for a nice sail, but anything can happen at any time. Super important to keep your head out of the boat. Factors that intersect with the weather to lead to a decision-making process about what to do, whether to leave, or how to handle the upcoming 6, 12, 24, 36 hours. Okay, what kind of a crew have I got together for this trip? How experienced are they? How much have we all worked together? Huge component, I think, of performance and safety is comms. How well does my crew know each other, and how well do they communicate? This is not a weather story, but I think it's a great story. I heard Russell Coutts interviewed once after a match race regatta in which he did not win, and he was doing an interview, and he said, "Oh yeah, and he was sailing with Simon Dobney, Warwick Fleury, the guys he sailed with his whole life, but hadn't sailed with in a year or 6 months." And he said, "Oh yeah, our communication was awful." Well, these guys have sailed together their whole lives, literally, had been away from each other and perceived that their communications loop was bad. So apply that, I think, very importantly from a safety standpoint to your crew and understanding, how well are people know each other? How well are they getting along? How well are we communicating what's going on around us and communicating expectations? Similarly, crew fatigue. How are we doing as a ship's company? Are we physically fit? Are we tired? Are we seasick? How are we doing emotionally? Just as important as a physical fitness is emotional fitness. And as I mentioned, crew chemistry. And then the ship, what kind of shape is she in? Have we been through a rough 4 days? Did we leave in a hurry? Did we forget stuff? Are there systems that aren't working? All of that one really needs to take into account in connection with the weather to figure out what's coming next. Again, everybody on this call probably knows this stuff, but it's easy to forget. And I think one of the big advantages of safety seminars like this one and the hands-on in the fall is simply standing down and spending time thinking about what we already know, thinking about the weather and other aspects of safety, and thinking safety. And finally, pre-departure or in the middle of a passage, what's my bailout here? How many opportunities do I have to seek safe harbor? What are my bailout plans to get away from bad weather? Rich's example of the container ship in the Bahamas is a great one of that, the El Faro. She went down partly because there was no bailout spot. She got stuck between Ernesto, or whatever that hurricane's name was, and the Bahamas, and there was nowhere to go. Keeping your options open from a weather standpoint is really important. Knowing if you have a bailout plan before you leave is really important, which brings me to the last little bit of my talk here, which is a real life example. In 2016, I owned a Class 40 and was campaigning it. And our schedule that spring was composed of the Atlantic Cup, which is kind of a semi-pro format, 3-leg regatta. And it also included the Bermuda race. And I do a whole talk on this particular spring and these particular decisions, but I've got just a couple slides to wind up here and remind everyone of Rule 3, which used to be rule 4. I'm not sure what in this new rule book jumped in front, but now rule 3, or what they took out, sorry, is the responsibility for a boat's decision to participate or to continue racing or cruising is hers and hers alone. Here are the 2 race courses. The Atlantic Cup and the leg was from Charleston to New York. We did 3 Atlantic Cups when I owned the Class 40, and this is a brutal race course. It's early in May. It's going to be cold until it's going to be hot and thunderstormy in the Gulf Stream until it's not, and then it's going to be cold. And this, of course, is, as everyone recognizes, the rum line from Newport to Bermuda. And I chose to display this race course over a satellite shot of the Gulf Stream. These shots, this is real-time satellite imagery showing sea surface temperature from Johns Hopkins. Unfortunately, the Johns Hopkins site is down right now and has been for a few weeks. I checked with Frank Boland to find out why, and even he doesn't know why, but hopefully this comes back because it's a super important tool. That spring in early May, we were comfortable starting this race, in fact, under a tropical storm warning. A month later, we chose not to start the 2016 Bermuda race, as about 40% of the fleet also chose, in front of a very dynamic and uncertain weather forecast. And I'll talk about the specifics briefly next. Thinking about awareness, on the left is a picture of us actually leaving Charleston that spring under the tropical storm warning. And you can see we were ready for a tough few hours. In that race, we had onboard reporters provided by the organizer. One nod to the forecast was that the OBR was confined to below decks for the first 36 hours of the race, which was really bad news for the OBR to have to be below in that kind of weather. And then on the right are the conditions we would have faced leaving Bermuda a month later. This is actually a picture of us leaving on the 2014 Bermuda race, but the conditions would have been the same on that day. So here we were taking off. Here were the conditions we would have taken off in, but decided not to. And here's the weather picture for each of those 2 days. This image on the left is from the National Hurricane Center. It showed the tropical storm approaching Charleston, our race start zone. A couple things about this. It was the 3rd issued advisory by the National Hurricane Center. So we were beginning to develop some confidence in the track. The track wasn't changing very much. The trend was for the storm to slow. And a good little weather ditty to keep in mind is that the trend is your friend. If you see a forecast that over subsequent forecast periods is getting worse, weather's probably going to get worse. If you see where the trend in the weather is moderating, it's probably going to moderate. So a few more things about the left-hand picture and Charleston that May was we knew from monitoring the National Hurricane Center that conditions aloft were not favorable for development. We knew that the storm was forecast to intensify at first, but then weaken and come ashore and slow down, which was the big thing. And then lastly, the escape route with the storm to the south of us happened to be right along the rum line. And you'll see that we left on this race on Saturday, even with this forecast that was slowing all the time. The storm was not forecast to reach Hatteras until Thursday, which gave us almost a 200% safety margin in our ability to clear out of Charleston, get down the trek, get around Hatteras before we might have encountered deteriorating conditions. So all of that said to us, okay, we can understand the risk here. There are only a couple of variables. We think the risk is manageable after analysis and a lot of discussion amongst the two of us. This is a double-handed race, and off we went. I will say that the wild card in that race was obligations in New York associated with that kind of pro-style race. which influenced the race organizers and influenced our decision. And I offer that little tidbit to emphasize, and this is what happened to the Bounty. She had to get somewhere important and under a time constraint, and that led to a bad decision. I like to think we were thinking about that in Charleston, aware of the fact that there was pressure on us to get down the track and figure that into our overall planning. And we went, but I like to think we would have resisted the temptation if we didn't feel it was safe to go. So in contrast, on the right is the synoptic picture when we woke up on race day for the Bermuda race a month later. Way more complicated. You can see there are a couple of systems here. One that was crossing the racetrack that day into a developing gale, here marked on the chart, into the Gulf Stream, which we all know is a multiplier of weather effects in the first order, and then a second system forecast to sweep out of the Great Lakes and reinforce a bad situation and make it worse. And in this zone here was right where two tropical depressions had formed in the last couple of weeks before the race. So conditions we knew were ripe for tropical development again. We knew that our timing was bad leaving Newport. We were forecast to, based on our routing information, to arrive right when this second low was going to get there. A lot of variables here. And maybe the most important difference between the two events over here and over here. In Charleston in May, we'd been in Charleston for over a week and a half. We were really well rested, The boat was in perfect condition, ready to go. In Newport in June, we had a frantic yard period after being holed in New York Harbor by a huge piling while the boat was on a mooring in between legs of the Atlantic Cup. So we had spent a very stressful and frantic yard period on the hard in Newport trying to get the boat fixed, which we did. I had a different double-handed partner in Newport than I had in Charleston. In fact, my regular partner came aboard in Newport, but he was in the middle of a little bit of a family emergency. His mind was not in the game. He didn't feel good. That made me not feel good. We were just not in a good emotional state to challenge the weather. And that figured very heavily into our decision, as well as the pure meteorological assessment of what was going on here, which, if I had to sum up in one word, was just complexity and uncertainty, combined with the fact that, effectively we had no bailout. We thought about setting out on the race and then turning back, but as everybody knows, once you go, you kind of go. And we felt as though no matter how bad the data got as we monitored things going along, once you're out there, and it's really unlikely that you're going to turn around. So that's a little bit of a hodgepodge, but a little bit, I hope, of talking about this three-legged stool in terms of weather safety, which is awareness of the big picture, what's going on, making sure you accumulate the proper information to make a decision, and then arraying that information, plus a lot of exogenous non-weather factors that have an impact on your state in the weather to make a decision about whether to go or no go, how to handle the ship over the next 6, 12, or 36 hours.